Hey guys, welcome back to Car Academy. In this series of video, we are looking into CEC337 DSP architecture and programming of Anna University Curriculum Regulations 2021. This series of video is not just meant for students but anyone who want to learn DSP architecture and programming. In the last couple of videos, we looked into installation of Code Composer Studio IDE and we wrote a very basic example of addition using Code Composer Studio. In this video, we are going to create a project and write a very basic image processing program using Code Composer Studio. So the program is very simple. We basically define a two-dimensional array and create an image using Code Composer Studio. So if you don't know how to open Code Composer Studio, please refer to the previous video that we posted in YouTube. So basically when you open Code Composer Studio, you will see this window and we basically create a new project. So a new project can be created like this: create project, click project, and then click new. Here you can give a project name. Here I'm giving a name, create image, and click finish. Check the other settings. So the project type should be executable .out, and you should also see the target as TMS320 C64XX. And once you click finish, you will see create img.pjt, and as usual you need a linker script which we save it as a linker.cmd. So please refer to the previous programs. So I will be basically using something like this. So the linker command looks like this. We will save this file as linker.cmd. Just go to sim64xx and go to your directory, create img. Here you save it as linker.cmd and add that file to your project. So select all, and here you should see linker.cmd. The file has been added to your project. Now let's go and create a C file. So just to make sure that the program compiles and runs properly, we'll basically just start with a hello world here, just to make sure that the program compiles. This particular file has been added. So create image.c. Let's add that file to this project by clicking add files. Okay, now the file has been added. Let's build the program by clicking this rebuild all button. So once you do that, you see some warning. That warning can be got ridden by just adding a new line to the last line. Now rebuild again, you should not see any warnings. You should see 0 errors, 0 warnings. The program has been loaded to the simulator. You click this button to run the program. Now you should see the result here in the std output. Okay, now let's go on. Now we know that this file has been compiled properly. Now let's go and write the simple image processing code. Okay, so here we'll basically define a pointer to store the image contents. Okay, we'll use two variables basically to pass between the x and y dimensions. I call it as a row and column. Image is basically a two-dimensional data. This two-dimensional data can be viewed something like a matrix where you have data in two dimensions, x and y, which we call it as also can be called as rows and columns. Okay, now what we do is basically allocate memory for the image. So for the purpose of this program, let's basically define the width of the image as 100 and the height of the image as 100. Okay, so here we are allocating memory for the image. Let's just allocate raw image. Basically, this is basically an 8-bit image. That is why you just allocate each pixel is basically 8-bit image means that each pixel is 8 bits wide. Okay. Now that we have allocated memory, let's print the address of the image pointer. It should not be 0. If it's 0, it's basically the allocation has been failed. Let's see if image is equal to null. Then what that means is we'll say printf buffer allocation failed. Okay, and we'll return from here. We can also return an error code. In this case, when it failed, we'll return -1, and in successful case, let's return 0. So let's see what happens in this case. So we'll build the program. Now there are a couple of variables we declared but haven't used. We'll use it in while creating the image. Now let's run. So now what happens is here the image pointer is 0. Okay, the buffer allocation has been failed. Okay, so now let's first fix this problem. So in order to fix this problem, you need to understand one thing. So basically what happens is we are trying to allocate width times height, which is basically 100 times 100. That is basically 10,000 bytes of memories we are trying to allocate in the heap. So that is something the program will go and take a look at the linker command. Here you see that heap memory is just 2000 hex bytes. Okay, but we are trying to allocate 10,000 bytes from the heap. Okay, so what we'll do is we'll just increase this heap to 0x20,000. Now let's rebuild this program and run it. Okay, now you get a pointer. Now you did not see the buffer allocation failed error. Okay, you got a value. Previously we got 0. Now we got a valid address, and this address you can see. This is basically an address coming from here. Okay, this is basically external, which I said it's a dynamic RAM or DRAM. So you see the address is basically 8000008. Okay, which is basically coming from here. And since we increase the heap, it's able to allocate 10,000 bytes for this image. Okay, now let's go and write this program. So I'm basically just doing so here I'm basically traversing over each and every pixel in both the x and y directions. I'm just so row times width plus column is equal to row plus column mod 256. Okay, so in an 8-bit image you can only have values between 0 and 255. So anything above 255 will have to be wrapped back to 0. So that's what I'm trying to accomplish with the modulo operation. So here I'm basically creating a nice gradient. Let's basically build this program. I will also show you how to view this image. Okay, so there is one important concept I'm trying to show you here. Okay, so there's one more thing we'll have to do here. We have allocated a buffer. We'll have to deallocate that. So that will be done by calling the free function. Okay, let's build this. So now it says, okay, so the program has been loaded to the memory. Now we can run this. So let's run this and see what happens. We did not see anything here. Okay, so now I want to see this image in some viewer. Okay, so for that what we can do is we cannot see the image after the program has completed running. Okay, so we'll have to see the image while the program is still running. How to do that? It just executes quickly. So the way to do that is I'm going to basically introduce a breakpoint. A breakpoint is something where the program halts its execution. So you can add a breakpoint by just double clicking in at this particular location. So here when I double click, I see a red dot. Okay, so when you see a red dot, what that means is the program will execute till that point and it stops executing from that particular line. Okay, so now let's rebuild or reload that program. Okay, so now when I run, what happens is you see a arrow at this red dot. Okay, so what that means is the program has run till this point and it stopped at this line. Okay, so when we click run again, it completes the execution. Okay, we can also do one more thing. You can insert as many breakpoints as you want. So we already have a breakpoint here. Now let me add a breakpoint here. Okay, so the program is loaded. Now when I run, what happens is it has allocated memory, but we haven't filled anything to this memory. So now let's go and take a look at the memory. So when you click view, there is something called watch window. Okay, that's one thing. There is also view memory. Okay, so let's go and take a look at the memory. I don't want the watch window, I'm closing it. So let's take a look at the memory window. So in this case, our buffer has a name image, so I'm just typing image here. So when we type the image, you can see. Okay, now let's go and fill something here. I will change the format here. So the format, the easiest format to understand is 8-bit unsigned integer. So it already has 0, 1, 2, 3, 4, 5. Now let's go and change this. Okay, so I'm changing this to 100, 120, 101. So you can change to whatever number you want. Now let's go and run this for loop. Okay, so when we run this for loop, you can see these values have been changed. So basically what happens is these two for loops will fill this image buffer. Now let's go and see how the image looks like. So for that, click view and then here click graph, and here you click image. So view, graph, image. So when you click that, you see a dialog box which has various values. Now I give image here. I mean it will be different in your case, but you will have to type properly image here. Okay, so I filled, since I tried the same program previously before recording this, so all the contents have been loaded properly. So this image has a dimension of 100 by 100. You will have to fill that properly. Now when we click OK, so note down all these parameters. You will have to fill these parameters correctly. Okay, so when you click OK, you see a nice image here. Okay, so this is what we have done in the first row. Basically it starts from 0 and you can see the value of the pixels here. I'm just showing the grayscale image as a RGB image. By you can also see the properties of this. So the properties is basically I'm giving the same buffer for all the three colors, red, green and blue. Okay, so it will have the same value, so 0, 0, 0, and when I move the pixel to the one position to the right, you will see 1, 1, 1, and you see 2, 2, 2, 3, 3, 3, 4, 4, 4. I'm just moving, and the last value should be 99, 99, 99. Okay, so we have our width as 100. It starts from 0 and ends at 99, 99. Okay, Now let me go back to the first pixel top left. I will start going down now. Okay, so if I go down now, it's 1 1 1 2 2 2. You can see the cursor moving in the image, and the last pixel should be 99 99 99, and here it goes from 99 till 198 198 198. So you can view the image like this, and the program is basically here. You can run and terminate this program. Okay, now the image is not found because the program has been completed. That particular address is no longer available. Okay, so this will either have some garbage, so you can also see a warning here. That's because the image is not found. Okay, so this is a very simple image processing program. If you like this video, subscribe to this channel, share it with your friends. We are going to learn more and more image processing and signal processing implementations on Code Composer Studio. Hope you like this content. Let me know what you want from me on the Code Composer Studio. I will basically create videos based on your interest. Till I find the next interesting concept, I'm signing off. Thank you guys. Bye.